I'm here on behalf of Neles to walk you through the setup and calibration of the VALVCON ADC-Series electric actuator. This video will include wiring, mode setting configurations, and detailed calibration information. Dangerous voltages are present inside the actuator. Please use extreme caution when working on the actuator with the cover removed. For portions of the following procedures, you will need a 1/16 hex or Allen head wrench and a small flat blade screwdriver. Depending on the desired control method, you will also need a 4 to 20 milliamp signal generator. The instructions in this video assume the cover of the actuator has already been removed. The actuator is factory configured for 2-wire CCW operation. To change the settings and/or fine-tune the actuator to the valve, damper, or other final drive element, perform the following. First, select desired limit type Smart or CAM by sliding the switch down to select CAM or up to select Smart. Selecting Smart will enable other features on the board such as position feedback and 3-position operation. Selecting CAM will allow the actuator to drive between the end of travel limit switch settings. Smart mode is the default configuration prior to shipment from the factory. Next, select control method, 2-wire CCW, 2-wire CW, 3-wire jog, or 3-wire latch, resistive or analog by turning the mode selection potentiometer with a small flat blade screwdriver. Field installation of the universal control board or replacement of the feedback potentiometer requires calibration of the potentiometer prior to setting positions and values for 0, mid, and span. Universal control boards installed at the factory are fully calibrated at the factory and should not require further calibration. However, the factory preset calibration may not match the device that the actuator is controlling. Therefore, you may need to recalibrate the actuator to fine-tune it for the application. To confirm proper potentiometer calibration, first turn the mode selector dial to Cal and then press Enter for 2 seconds. Using the CW push button, drive the actuator to the full clockwise position as viewed from above. For our demonstration, the valve we have is fully open at the full clockwise position. If the Cal LED remains on, no calibration is required. Proceed to the setting 0, mid, and span position section. If the Cal LED is flashing, potentiometer calibration is required. Again, at the full clockwise position as viewed from above the actuator. To calibrate, loosen the set screw in the cam shaft gear with a 1/16 hex or Allen head wrench. The LED assists the user in locating the proper calibration window by flashing faster as you approach the calibration window and slower as you move away from it. Rotate the gear until the LED remains on constantly and tighten the set screw. Ensure that the LED remains lit after the set screw is tightened. Press the Enter button to save the potentiometer setting. Once feedback potentiometer calibration has been confirmed, set the desired end of travel positions. Make certain that the limit switch cams are set to operate the switches beyond the desired range for the 0 and span positions. To control the actuator with a 4 to 20 milliamps or 0 to 10 volts DC analog signal, first, slide the input switch up to select 0 to 10 volts or down to select 4 to 20 milliamps. Select analog in the position control region of the mode selector. Then connect milliamps or volts DC positive to terminal 15 and the milliamps or volts DC negative to terminal 16 on the universal control board. Turn the mode selector dial to 0 and press Enter for 2 seconds. The 0 LED will begin to flash. Drive the actuator to the desired clockwise position using the CW or CCW push buttons. If the stall LED begins to flash, check to see if the limit switch cam is preventing the actuator from reaching the desired 0 end of travel. If this is the case, the switch trip LED will be illuminated. If necessary, back the cam off so it trips the switch slightly beyond the desired end of travel, at which time the switch trip LED will go out. If configuring for an on-off mode, a signal is not required. However, if using the analog or resistive control mode, apply the desired 0 position signal. Typically, this will be 4 milliamps. Press the Enter button to save the 0 setting. To set the optional mid position, this would only apply with 3-wire jog on-off control mode. Turn the mode selector dial to mid and press Enter for 2 seconds. The mid LED will begin to flash. Drive the actuator to the desired mid or third position using the CW or CCW push button. Press the Enter button to save the mid setting. In our demonstration, no mid setting is necessary, so we can move on to span. Turn the mode selector dial to span and press Enter for 2 seconds. The span LED will begin to flash. Drive the actuator to the desired counterclockwise position using the CW or CCW push button. If the stall LED begins to flash, check to see if the limit switch cam is preventing the actuator from reaching the desired span end of travel, at which point the switch trip LED will be illuminated. If necessary, back the cam off so that it will trip the switch slightly beyond the desired end of travel and the switch trip LED will go out. If configuring for an on-off mode, a signal is not required. However, if using the analog or resistive control mode, apply the desired span position signal. Typically this will be 20 milliamps. Press the Enter button to save the span setting. To verify end of travel settings, turn the mode selector dial to Run. Apply various control signals to verify operation. Verify the switch trip LED is not illuminated at either the 0 or span positions. If it is, back the respective end of travel cam off the respective limit switch. When using the analog position control mode, the board can be set up to respond to a loss of control signal when external power is still present. The board can be set to drive the actuator to the save 0. Typically, this is the minimum signal position. The saved span, typically this is the maximum signal position, or to fail in place, the last position the unit was in when the signal was lost. To set this position, slide the selector switch all the way up to select 0, to the middle position to select span, or all the way down to select last. There is also a deadband adjustment that will increase or decrease the actuator's sensitivity to a signal change. This can be used to eliminate hunting if there is noise on the control signal. The minimum deadband will provide the most sensitive response. We recommend using the lowest setting at which no hunting occurs. As a standard feature, the unit also is equipped with position feedback. First, we'll select milliamps or voltage. Slide the selector switch down for 4 to 20 milliamps or up for 0 to 10 volts DC. The feedback signal can be generated internally or it can be loop powered. To use loop power, slide the selector down to select external mode. To use the internally generated signal, slide the selector up to select internal mode. The feedback signal is wired to terminals 5, 6, and 7, where only terminal 5 negative and terminal 7 positive are used for an internally generated feedback signal. And all 3 terminals may be used with a loop-powered signal, but depending on the configuration, it may only be necessary to connect terminals 6, 24 volts DC positive, and 7 feedback signal negative. For more detailed information on feedback signal wiring, please see the IMO supplied with the actuator or scan the QR code label on the actuator base to open the IMO on your mobile device. If the actuator includes the optional battery backup, there are a few more selections to make. The actuator can be configured to park, meaning it will drive to the fail position immediately upon loss of external power. Or we can select multi, whereby the unit will continue to respond to a control signal if still present using battery power. The default configuration is park. Selector switch is up. To select multi, move the switch down. If multi-mode is selected, the unit will continue to respond to a control signal until either the signal is lost or the battery level reaches a low-level threshold. In either case, the battery will drive the actuator to the park position. Finally, we need to select the fail position. The actuator can drive to the full clockwise position, to a mid position, or the full counterclockwise position. To change this setting, Use a small flat blade screwdriver to turn the power fail control selector. To properly replace the actuator cover, remove the override shaft from the actuator cover bushing. If the actuator is equipped with a hand wheel, remove the hand wheel before removing the top piece of the two-piece shaft from the cover bushing. Install the override shaft on the square motor shaft. If equipped with a hand wheel, install the bottom piece of the two-piece shaft on the motor shaft, and then install the top piece of the shaft onto the bottom piece of the shaft. Align the cover so the override shaft passes through the override bushing, and carefully push it down so the cover flange contacts the base flange. Once the cover is properly seated, secure the cover by tightening the screws in a cross pattern, which assists with uniform load distribution. If the position indicator is not seated to the output camshaft, turn the indicator until it drops into place. This will ensure accurate visual position indication. Thanks for your attention. If you have any further questions, please feel free to visit our website.